To achieve these characteristics, the scara type robot was used as basis for the design. After analyzing the length of the links, a size of 15 centimeters for each link was established for the design. To fix the link in each servo motor, an aluminum hub with a set screw was made by turning in the manual lathe. To fix the upper part of the hub to the link, an structural adhesive was used. It was important to apply pressure in the first 5 minutes to keep the components in position to avoid misplacing in the design. To move the end effector, a gear and a zipper were 3D printed and attached to the pen and mini servo respectively.
To move manually the robot, we define an interface by processing. On this interface we set 3 layers, one red, one green and one blue, and each of them define one of the servo motors. The first one is for the body, the second one for the arm, and the last one for the final effector. The code is based on the serial communication. All the data is sending by serial from processing to the Arduino, and then it's divided by a comma, and each of the values is for an array of the variable servo. And thanks to it, we can define which servo we are going to move and in how many degrees. An example of this could be seen on this, when I define for the body, now for the arm, and finally for the final effector. And that's the manual operation of our robot.
The processing interface, we could create a way in which we could command the motors depending on whether they are at the base, at the arm or at the end effector. We can control it manually through the left side of the interface. Here we can choose the angle of each of the motors. Here the red slider indicates the angle of the motor at the base of the robot. Then we have the green slider, which indicates the angle at which the motor of the arm is supposed to be. And lastly, we have the angle of the end effector, which will go up and down depending on which one we choose. This will only work if we click on the interface, as we can see right now. And on the right side of the interface we have the forward kinematics version of the interface. Here we can directly choose the angle of each motor, and here it displays which angle is being chosen. And at the bottom right corner we have the angle at which the end effector is supposed to go. Here we have the position based on the X and Y axis. Here on the bottom left corner of our workspace we have the reference frame in which we made all the calculations needed for the position of the end effector. We used basic trigonometry, and we determined the orientation of both the robot and the workspace to be the same, so we could simplify the problem. So for example, we can choose a 90-degree angle for the motor at the base of the robot, and then we can choose a 29-ish angle for the motor at the arm of the robot, and then we will find it to be at one of the corners. So we can see that there's a little bit of error thanks to the imprecision of the motors. And here we have that it's almost completely supposed to be at the corner, but we can see that there's a little difference. And lastly, we have to choose an angle, and then we can hit the send button, which will give the instructions for the robot to move to said point.